The Network Innovation Laboratories have developed a multi-carrier, multi-rate modem for satellite communications, which can transmit and receive multiple radio channels simultaneously. The key feature of satellite communications is that all Earth stations connect to the system via the same satellite transponder, which makes it possible to communicate with multiple points simultaneously. In other words, multiple users can share various kinds of content, such as video, audio, and Internet Protocol data in real time. To communicate with multiple points, however, a conventional Earth station requires a number of modems, one for each point. In addition, because required bandwidth differs according to content, bandwidth must be set accordingly for each radio channel. These requirements result in massive equipment and an unreasonable cost of Earth stations. In contrast, the developed multi-carrier multi-rate modem can simultaneously transmit and receive radio channels among multiple points by one small unit. It can also handle diverse contents of different bandwidth, such as video, audio, and data at the same time. This multi-carrier multi-rate modem can perform modulation and demodulation for a maximum of 256 carriers, and it can support simultaneous bidirectional communication among 128 points. It also enables efficient broadband data transmission by utilizing several unused narrow frequency bands. To enable multiple Earth stations to communicate with each other via the satellite, FDMA is the most common approach. It allocates each radio channel a slot on the frequency axis according to its bandwidth. This figure shows an example of channel assignment. Here we can envision a new channel request having a relatively large bandwidth. However, there is no contiguous empty bandwidth large enough to accommodate this request. In this case, the conventional approach has been to temporarily cut off other channels currently in use and then rearrange allocations to obtain the necessary bandwidth. The new approach using the developed modem requires neither channel cutoff nor rearrangement. At the transmitter side, a radio channel is sliced into multiple carriers. These carriers are then distributed over the available bandwidth of the satellite transponder. Finally, the receiver side restores the transmitted data using multi-carrier demodulation and bandwidth reconstruction functions on the modem. This multi-carrier multi-rate modem can configure a multi-point mesh network that makes full use of satellite communication features while using low-cost Earth station equipment. We expect it to become widely used in both corporate and public networks that adopt satellite communications.